Thank you guys for having me. That was two great presentations. Hey, thanks. That was two great presentations before me. So we talk a little bit about learning. We talk a little bit about having fun with games and music. So now we're gonna get serious. We're gonna talk about work. So I'll start with my story. So two years and a half ago, I started a company called Ifworks, which is a blockchain software house. And we've been very lucky to work with one of the best customers in the blockchain space. And it was especially challenging for me because I do have a technical background, but when I was starting a company, I spent almost 10 years in management. So I didn't have a lot of practice, and I was not very fluent on programming, and I knew if I want to create a quality software house, I will need to go back to coding and build the engineering culture from the very beginning. So that was a challenge. That was a challenge I faced 2 years ago. In those 2 years, we started two open source projects. One is called Waffle. Waffle became pretty popular in certain communities that build sophisticated blockchain-related projects. This is a testing library for smart contracts. Smart contracts are something in the heart of blockchain applications. And then a little bit later, we started, also a little bit over a year ago, we started Universal Login. And Universal Login is also an open source project. You can see there's already a lot of people like following and forking the project, even though it's not yet production ready, it's not yet stable. And it became pretty big and complicated project that we work on. There is a full-time team of 3, 4, sometimes 5 people working on the project, running for over a year. So how did I approach it? How do I go back to engineering? How do I build this culture? So one of the first questions I asked myself is, what is good engineering? And I was always asking myself that question, and especially it became relevant when I tried to when I was setting the company and starting the projects. Well, I would always argue back in my days that good engineering is the kind of engineering that leads into performance. That is performance. What does it mean, performance? Well, I think there is the obvious answer is software delivery performance. If we're able to develop and deliver fast, that's a good thing, right? That's very intuitive. Like, okay, you're slow, it takes forever to do things. Yeah, you're not good. You know, takes you an hour, boom, it's working, no bugs, good stuff, right? Also, important, I would argue, is organizational performance. So it's not enough that we produce a software. It's important that the software successfully bring the value to the company. The company is earning money, they have a lot of happy customers, and so on and so forth. And of course, me as a company founder, I would still value those things a little bit less than you would, but still I would say it's important to like your work, to have a job satisfaction, to work on things that you like, to build something once, not go back and forth, not to stress about deadline deploys, and don't develop a burnout over the course of time. And it's really hard sometimes to think about what the good software engineering is, because there's so many buzzwords. There's like, you should use React. React is not good enough. You should add Redux to that. Yeah, that was a year ago. Now it's all about Angular, And on the backend you have Rails. No, that was 2 years ago. Now it's all about Node, right? So it's super, and you should be agile. You should do test-driven development, no SQL. Also this year it's Vue, no Angular anymore, And it's really, really difficult. And this cloud of all the possibilities to pick what is really important, right? And I would know something about it because a little bit more than 3 years ago, I wrote a blog post called Hype-Driven Development, when I shared my frustration with developers making decisions, just jumping on the next hype, rewriting application to the newest framework, or switching the database to newest, best database. And it went viral, and I had always over 250,000 views and over 100 million people read the article all over the world. It was translated to like 15 languages. It was crazy. Like for weeks I would discover new translation, Chinese, Italian, French, all that kind of stuff. So it seems that not this is not only my opinion, but a lot of people relate to that problem. So, so we are programmers, right? So we like scientific thinking. We are scientifically minded people, right? There are things that work and don't. You can do experiment, you can do research, and you can figure it out, right? So it would be best if there would only be possible to do a research and figure out what works, what doesn't, right? Boom. So those guys who wrote that book, it's called Accelerate, they spent a couple of years doing research in computer science, figuring out what works, what leads to performance. And they continue the research, that keep updating the research, and it took them a couple of years, but they basically built this table over the years. This is the last year's table. So they actually, when the book originally was written, the table was a little bit different, so they keep updating the research results. So what they say, when they pull all the data, they question all the people, like they question thousands of developers in hundreds of different teams across hundreds of companies, and they ask them a lot of questions about how they work and how performant they are. And they at the end of the whole thing, they did what's called clustering. So they try to find groups that are alike, and they find 5 groups. They find elite performance, high performance, medium performance, low performance, and misguided performance. And you can imagine those are the fastest guys, those are the slowest guys. And what they discover is there are patterns in how they work that determine how fast they deliver. So the elite performance will deploy to production very fast, very often, like multiple times during the day they would deploy to production. Okay? And then the high performance would do it very often too, but not as many times, perhaps once a day. Medium performance, once a week, maybe once a month. Low performance, like once a month. And like if you deploy like every couple months, you're probably a low performer. Okay? And there is a number of different properties. So there is a deployment frequency, but also lead time. How much time does it take from when I commit my changes to the repository? How much time does it take for it to get to production, right? And again, elite performance, it would be in less than an hour. So I work on something, I commit, boom, in an hour it's on production, right? And then, lower values, and eventually misguided performers are like, okay, it's gonna take 6 months. I'm writing something, and 6 months someone may be gonna use it, right? There are different things like how much time does it call to restore the service? If we have a failure, how much time does it take? If something goes down, how much time does it take to get back it online? And change failure rate. How often we deploy and something actually goes wrong? How often does that happen? And of course, the lesser I have, the more performant I am. And of course, the less time it takes to restore the service, the more performant I am. And they came up with this. So this is like all dependencies, all the different practices. This is like 20 practices that you can do out of hundreds that they were asking about. And they say, this 20 actually matters. Okay? Ooh, 20. Good. So before we go into all the different practices, let's examine what is there to win. What is the game about? What is there that we can learn, what we can gain? So first of all, software delivery performance. So the very thing we were asking about, ability to deliver fast. Okay, that's cool. Additionally, we have identity. So people who work in those teams are happy to work for that companies. They are proud to work for those companies. So this is something they would like to share. They feel there is a connection between their work and company, and they personally like it. Less burnout. So they can work for years and still be happy about their work. Less deployment pain. There is no stress, less deadlines and all that stuff. And less rework. So we deliver something, it works, boom, we're off to the next one. We're not coming back and reworking and fixing bugs and all that stuff. But that also interestingly leads to organizational performance. So the company earns more money. Well, we deliver fast. We know what the customer wants. Boom, we deliver. They buy, they're happy, they buy more. And additionally, we also have non-commercial performance. So not only we earn money, but we actually deliver quality stuff. Like customer says, yeah, this is good stuff that I'm buying, and I'm also recommending to a friend. This is good stuff, right? I'm not just using because I have to, but I also like to use it, right? It's no buggy, it's all that stuff, right? We have a job satisfaction, so that's pretty clear. And this is also Western organization culture, meaning like, you know, Eastern organization and culture would be more hierarchical, more like deadline driven, more like power oriented, while Western would be more relaxed, more like goal oriented. You find your own way how to do that, and so on. So this is all to gain. So this is win-win, right? I'm happy, I'm leading a company, our customers are happy, we're good at delivery, they earn money, customers are happy, and people working on the projects are happy. They like to work on here. So that sounds like a valuable thing to have. Would you agree? Yeah. Good. So let's see what's on the left. What do we have to do? So there is a bunch of practices like working in small batches, making flow of work visible, like, you know, Kanban, stickers, you probably all know that stuff. Working with the customer and gathering feedback, and experimentation, figuring out together as a team what works. So this is what, there was a book, who knows Lean Startup book? Okay, I think roughly maybe a half of the team. So this is Lean Startup, right? So we're not talking about that. If you don't know what it is, you probably should read the book. This is like a Bible of our industry. Everybody should read about Lean Startup. But we're not talking about it today. Then there is a lean management, like limiting amount of work in progress. Like, I'm not working on 3 different tickets. I'm not working on 5 different tasks. Like, I get one, get it done, get the next one, right? Visual management, so again, tasks as stickers, feedback from production. So this is very similar. This is lightweight change approvals, like being able to get approval to get your stuff to production very fast. This is called Agile, and I'm pretty sure, and I ask who heard about Agile, it's going to be more than majority. Don't be shy. I think I'm pretty sure some people are, the hands are tired now, so good. So what we're going to focus on is this third part, which is engineering practices. So we're going to go about it in a moment. But before that, if you look, there is a very interesting thing. All the engineering practices leads to one thing called continuous delivery. And then that all leads to identity, less burnout, less deployment plan, more software delivery performance. So that's very interesting. There's just this one very important thing, continuous delivery, that is kind of like a must-have. And probably when I say about Lean Startup and Agile, the majority of the room knows what I'm talking about. But who knows what continuous delivery is? Okay, well, actually a lot of people. So who can tell me what continuous delivery is? Boom, nobody. Okay, there's one guy at the end. Yeah. So it's important part of it, like being ability when you push to repository, it's automatically tested and then goes to production. Broader speaking, it's ability to automatically deliver, like continuously, like on daily basis, hourly basis, continuously deliver your stuff to production. Boom. So this is continuous delivery, and let's look at the engineering practices that we need to what? Here it is. So we have a lot of practices. We have test automation, deployment automation, trunk-based development, shift level on security, loosely coupled architecture, empower teams, continuous integration, version control, test data management, monitoring, proactive notification. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 things. Whew, that's a lot of things to think about. So I'm gonna, there's something wrong with slides. Okay, anyway. So I'm gonna focus on some of them. I don't think we have enough time to talk about all of them. And I'm going to talk about the most controversial ones today. So automated tests. So it's funny because it was controversial topic 10 years ago when I was starting my career, and it's still controversial topic. So there's this thing called test-driven development. There's this idea, who knows what a test-driven development is? Okay, over half of. Who actually did write some code in test-driven development. Okay, there's 5, 6, 7, 9, 10 people who uses test-driven development on daily basis. 4.5. Well, there's one gentleman that is like, in the morning, a little bit of tests, in the evening, maybe a little bit less. Good. So there's this practice that you start with writing tests, then you implement the test, then you refactor and all that kind of cycle. We ain't gonna go into all the details. I can tell you this. It takes a lot of time to learn it, and for the 2.5 years, we still don't feel like we're really, really good at it, but we feel we're good at it, and it takes forever to learn. But that's very important, because without automated test suite, it's really difficult to do continuous delivery, because you deliver something to production, then it breaks on production, then you have to fix it, and then, the spiral is going down and you're not able to deliver quickly. And it's very important. The other thing that, again, I ain't gonna talk today, we did a great workshop last year on test-driven development with Piotr. Maybe we're gonna do another one. So if you would like to learn a little bit more about it and see how it works, then I encourage you to sign up once it's official. But it's super important to be able to write those good tests, those a lot of fast unit tests, less integration tests, and a little bit slow, more expensive end-to-end tests. And again, it takes many months, if not years, to learn to do it properly. And I'm just saying it for you today because it's very important. If you don't start with that, it's going to be super hard to implement all the other stuff. Trunk-based development. If I would only get 1 Bitcoin every time I have a conversation with someone about trunk-based development, I would have plenty of Bitcoins today. So here is, I think it's called Git workflow for agile teams. Who knows what I'm talking about? Okay, a bunch of people. Who uses that? Yeah, a bunch of people. Is that good stuff? Agile Git workflow? Yeah, some people say it's good. Good. So the idea of Agile Git workflow is kind of simple. If I start to develop a new feature, I do it on a feature branch. And then, once the feature is ready, I'm going to merge it to a develop branch. So there is like a develop branch that we keep developing on. And when we feel like, okay, this is ready stuff, we can release it, we merge it to release branch. And then maybe there is a master branch that every time we release, we tag a new version in the master branch, right? So that's very popular. A lot of people, like external teams we're working with, they do feature. So yeah, we don't do that. Yeah, that sucks. And that's funny because I was advocating it for 10 years and good. So another way to think about it, another way to think about Agile Git workflow is that you have this main branch like master, and you create all the branch from that. In trunk-based development, it's the opposite. So what you do is you're always committing to the master. And only every now and then you maybe do a fork with the release branch. So there are no feature branches, or at least very short living feature branches, like day long, maybe 2 days long. And you only fork it to have a release branch. So if you need to do a hotfix, you can do it on a release branch, but you're always merging to the master, and you always deploy master to production. Does that make sense? Okay, one person says it makes sense. But I can see some skepticism on some. Yeah. How do you scale it? How do you do when you have 100 people in your team, right? If you have 10 people, they commit to that master, right? If you have 100 team with Agile workflow, you have a bunch of branches. How do you scale it? Well, here's what you do. Everybody merge all the time to master branch. Who's a little bit more skeptical now? Okay, there is a guy at the end that is definitely skeptical now. Well, here's the funny thing. That's how big companies work. So this is how, if you go to Facebook, Google, and all that stuff, they keep deploying all the time. And Facebook go through thousands of deployments daily. And if you deploy something, if you write a code and you push it to a repository in Facebook, in the evening your grandma gonna be able to use it, right? So this is how people work. It takes a lot of effort to learn to work that way. because it's really difficult to work in small batches that you're able to build something and commit to master in couple hours. So, but that's important. And it took me, and I was advocating it for 10 years now. I didn't even know it's called trunk development. But now we have a scientific research that proves, hey, this is actually more performant than using Agile Git workflow. So that's huge relief for me. Good. Another thing is loosely coupled architecture. And so a lot of people advocating using Angular or using React with Redux and focusing on all that frameworks. And that's one way to go. But there is nothing in the research about specific frameworks. But what they say, loosely coupled architecture leads to a higher performance. And we know some examples of loosely coupled architecture. One example is, for example, microservices. The problem with microservices is that it's pretty complex, and you need to have a lot of DevOps knowledge in the team, and it's really complex. You should probably not do microservices unless you really know what you're doing. So we found a lighter architecture for us. It's domain-driven, design-inspired architecture. So domain-driven is kind of like the whole big thing. We're not doing the whole thing, but we're using the architecture that they're proposing with 4 layers, which is a little bit different than most of the architecture, because most of the architecture says about three layers, right? There's always 3 layers, well, 5 layers, but really 3 layers of your software, and then, the browser and the database as a 4th and 5th layer. So what we do, we have a very thin user interface layer. We have an application layer, domain and infrastructure. So domain is the thing that we're building, like the pure model of reality that we're modeling. Right, this is pure JavaScript. I think maybe I have that on the next slide. Let's see. Yeah. So this is pure JavaScript, TypeScript in particular in our case. Application layer is every logic that relates to user interface, but it's all in pure TypeScript as well. And then in the front end, we have React. We have pure React, no Redux, no code. There should be no code doing any logic of React components, because we move it all down here. And then there is an infrastructure layer. So for user interface, the infrastructure layer is going to be HTTP, right? Or the AJAX request goes from the thin layer. So this is thin, this is thin, this is fat. And because we're blockchain guys, we also talk to the blockchain from the interface. And so this is exactly that. So there is a pattern, pretty popular, smart and dumb components. Who knows smart and dumb components in React? Okay, not that many people, I think like a third of the room. So you do a dump component that only does the look of the components, HTML, CSS, and you inject all the stuff from smart components to that. All the logic is in the smart component. So we don't do that. We don't have smart components at all. Instead of having it a layer above, we put it a layer below. And all the logic is kept in pure TypeScript that is easy to test. It's easy to pin to another component. We can take the same logic and now connect it with the other component. We can test it with a unit test. We can test it with integration tests. It's super easy to test. Good. Good. And the funny thing is, you can use that architecture for any type of application. You can use it for front end, from backend, for mobile, for embedded. You can use it for smart contracts, whatever you want, right? So, for example, when we write backend, it's exactly the same. It's the difference is the user interface layer is now Express.js. Okay, so it's routers and maybe middlewares. But those routers and middlewares are very minimalistic. We don't put any logic there. We put all the logic in the application layer. So if we need to convert the request into something that domains understand, that's an application layer. If we need to validate the data, it's an application layer. Pure TypeScript. We can test it with units. We can test it with integration. It's super cheap. It's super easy to write, super easy to read, super easy to test. And then again, we have infrastructure. We don't do AJAXs here anymore. We do SQL, like we talk to the database and of course to the blockchain, because we're the blockchain guys. And boom, we can do that for mobile as well, right? So once you know the architecture, you can use it on any platform you want, right? And the only difference is we have now React Native here and HTTP and blockchain as we had in previous examples. And what about if we write a library in JavaScript for backend or frontend? We can use that architecture again, right? Again, we put all the domain here. The user interface is now just pure API in JavaScript. If there is anything that differs the perfect reality that we model from actual API because of any technical details, then we put it in the application layer. And again, talking to HTTP and blockchain because we're the blockchain guys. Which brings us to the next topic, which is unified technological stack. We use JavaScript everywhere, on mobile, on frontend, on backend. So now one person that knows how to do frontend, it takes just a couple days to move that person to the backend because he already knows the architecture, he already knows the language. He needs to learn a little bit of frameworks, not a lot, just React. No need to know Redux, no need to use RX, no need to use all that complicated stuff. You just need to know React. Good. And also tooling. We have a lot of code in the tooling as well. Blockchain is fairly new, kid around the block, so there's a lot of tooling that you have to build yourself, including some of the things. And maybe one interesting version control was another practice. And when I say version control, I'm guessing a lot of you think about, oh yeah, we use Git, version control, we're good, right? Maybe using agile workflow instead of trunk development, but it's Git. So the version control in the context of Accelerate means we're using version control to store all the artifacts of the project in one repository. So we have one repository that contains all the code, maybe backend, maybe frontend as well, maybe mobile, maybe tooling, all the deployment configuration, all the servers, and it's all in one repository, right? So for example, if you look at the universal login, which is one of the open source projects I was mentioning at the beginning, you can see that all of that is stored in one repository. And there is one build process for that, and there is one testing process for that. So we can very simply write a thing that puts it all together and run end-to-end tests that start on the front end and goes all the way down with the backend, blockchain, and all the stuff included. We can even build the workflows, although I don't think we did, that start on the mobile and finishes on the web. So that's another very interesting thing. Pair programming is so it is difficult to build that engineering culture. There's a lot of unintuitive things, a lot of controversial things. So one practice that helps us a lot is pair programming that I'm now advocating for many, many years. And we do a little bit of that. There is my team sitting over there, so you can ask them how much actually of that stuff we're really doing. So pair programming, on every retrospection, there is a sticker that says we should do more pair programming. So I'm not sure if it's good or bad, because it means we don't do it enough, but we value it. But basically, there is a technique called ping-pong pair programming, when one person writes tests, another person writes implementation, and you go back and forth, then you refactor, and that's a very good practice to learn all that stuff. Because it's really difficult to learn it from books. It's really difficult to learn it otherwise than practicing, and it's difficult to learn if you want to just practice alone. It's much easier to learn it if you're working with someone who already knows how to do that. So that's, I think, very valuable practice, although it's not in the part of the Accelerate pattern, right? And then there is a simple pair programming. One person writes tests, it fails. Another kind of person make it work and maybe refactor it to make it right. And then writes a test for another person that fails, and then the other person again implements it, refactor it, and writes tests for the first person. But there is a nice version. Someone called it undersmanship version. When you write a test, someone implements and writes a test, but someone writes an implementation, but the implementation is stupid, right? So you say 31 plus 1 should equal 32. And then I'm implementing add and say, okay, return 32, right? And then it's like, I have to find a way to write a test that kind of is exhaustive and fights all the way that the developer cannot cheat on the implementation. So that's a fun thing to do. It's not something we kind of advocate to do, but I thought it's worth mentioning. And another thing that we're kind of doing, which is also part of building engineering culture, is that we build a path. We call it adventure path, so the way to develop your skills over time. And part of that path, if you want to go from junior, medium, senior level, all the way to principal engineer, you need to show practical execution of those skills, right? So if you want to go from let's say junior 5 to medium level developer, then you already have to have a nice culture of writing tests, have a track record of delivery of the projects that are well tested, and so on and so forth. So that really makes it more makes the incentive aligned with good engineering culture. Good. So maybe you have some questions, but before you have a question, I have a question to you. So what's the one question? If you would like to judge a team by what you had only one question to ask to see if they're in a high performer group or low performer group or medium performer, what would be the question? Boom. I think this guy deserves a free Confront.js ticket. Good. So that's all from me.
What was the answer?
The answer was, I'll repeat the answer. The answer is, how many deploys do you do a day? It's probably if you have a single question to ask and you want to judge how good is the team, how performant, it's probably the best question to ask. Although I advocate against judging the team by one question in general.
Congratulations for winning the ticket!
There is nothing more fun than give away someone else's prize. Yeah.
Whoa, I wasn't expecting that. This guy, he's ready. So just someone say something smart. Quick. Okay. Any more questions?
Kacper is coming with a question. I see so many old faces today on WarsawJS.
He's not that old.
Come on.
Okay, so
I have a feeling that some people came just to see me today.
Okay, so the question is, how much of the test-driven development comes from the fact that you're, for example, programming in Ruby or like the language where errors will be seen at the execution time and not at the compile time, right? So
that's a funny question for me. So the question, so I come from the Ruby background. I spent a lot of time in the Ruby on Rails community. There are some people from Ruby on Rails community sitting right behind you, so they can confirm. And they ain't gonna like what I'm gonna say. So I think Ruby is a shitty language, and it makes it super hard to do test-driven development. And this is a real story, and it was so in this article I mentioned there was a Rails creator David Heisen. Rails guys, please help me. No help from Rails guys now. So there was an article that says TDD is that from the creator of Rails, Ruby on Rails. So that's how much Ruby on Rails back in the days, maybe it's different now, how much Ruby on Rails environment valued TDD. And I would describe that in this article. There was a response from Kent Beck, which I also quoted, which says TDD is not dead or alive. It's a subject of consideration of the technology at hand, team skills of the team, and so on and so forth. So what we're doing now is we write everything in TypeScript. And I think TypeScript is kind of strongly typed, compiled kind of thing, although it's kind of somewhere in the middle. I think it doesn't matter what language you code, like test-driven is a good choice. And in general, I think strongly typed languages are better, especially TypeScript became really good over the years. And so I don't think there is a connection between the language you write and should you or should you not use test-driven development. But there are other considerations.
Okay, here we go.
I have a question about the feature branch versus track branching. What about the code review? Because if you have a feature branch, you can easily make a code review for the developer regarding this one feature. But if you're uploading, if you're pushing to the one branch, it can be overwhelming, I think.
So technically, we do use branches. So like there are short-living branches, like 1 day, 2 day, 2 day. It's a lifetime of the branch, but it's normal to have a branch that lives for an hour or two. And we generally like to slice those features into many pull requests because small pull requests are easy to review. So we use GitHub in most of the projects, so it's very natural to work on branches. So in that sense, the branches still exist. We don't call it feature branches, and we don't. And for us, it's a technical detail to do a code review, right? It's not. There is no branching strategy. There is no branch from the branch merging and all that stuff, right?
That's incredible.
There is Krzysztof has a question over there.
Where is he? In the next building. Okay, here we go. Of course. Here, Zoe.
So this is a follow-up question to the previous question. So if you split one feature to multiple pull requests, then you have this problem that you have, some work done on master branch. So do you use feature switches to hide it until it's done, or is it something else?
Question. It's a lovely question. So there is this thing called feature toggles. Who heard about feature toggles? Oh, surprisingly a lot of features. So there is the idea that if you work on that one branch and you have a feature that's gonna take 3 months to develop, you hide it behind a feature toggle. And feature toggle is simply like a Boolean variable that says, should you be able to use that feature or not? And then on your beta environment, on your local environment, the switch is on, and then on production, the switch is off, right? So there is like for example, when Google develops their products, there is internally they have different versions than the outside world. They are like let's say 2 weeks ahead of the rest, right? They also do incremental rollout, so some different people can have different versions basically, right? So there is Google employees has the yesterday version, the small beta tester users, maybe under 1% of users have 2 weeks old version, and all the people have 1 month old version, right? There is a thing called Gatekeeper in Facebook that allows you to see, those future features, right? So when I was learning about those techniques back in the days, feature branch, trunk development and feature branches back in the days, I thought it's very important. I even developed a framework for feature branches. Then later discovered there is a framework for feature branches and so on and so forth. But the reality is you surprisingly rarely you actually need feature branches. First of all, if you do need, keep it simple. Make it a Boolean, make it an environmental variable. Don't forget to store the value of the variable in the repository though. But make it very simple. But oftentimes you can just go to another URL to show the feature, right? There is a hidden URL. Or there is you allow your features, you allow people to sign up to beta, and beta guys have newer version. Or there is a beta.yourproject.com that has most recent version, and once a week you deploy it to production, right? So all that stuff usually is good enough to, surprisingly rarely you actually need feature branches. If you get really good at, working in small increments and refactor towards features rather than build features. Any other questions? There is a question from the back. So I'll
go over.
So there is a lot of people from crypto community today here. So
I saw that you are using the monorepo.
Mm-hmm.
And I have the question, do you have any need for that one from this repository is handled differently for some client, or have to have some different implementation in some cases? And if so, how do you handle this?
What would be an example of such a problem?
For instance, you have like some client that have some special needs, and you have to like develop some feature just for him, and but the main baseline product have to have different.
So first of all, there are places where we struggle with monorepo. One example is React Native. React Native has its own compile pipeline, and React and all TypeScript has its own. So it's kind of, we still keep it in monorepo, but it's kind of annoying to have two build processes in one repository. Sorry. Another example when we struggle is when we want to have a big open source part of the project and big private part of the project. That's also a problem. The problem you mentioned in particular, I would advocate, regardless of monorepo strategy, I would argue you should never fork your code. Because then when you want to backport functionalities, it's going to become, at some point you're just managing two different projects. So unless you want to manage two different projects, you probably don't want to do that. So what you do is you configure your project, right? You put, okay, this guy needs this custom feature, so there's this feature flag for that guy. Also, I would argue it's very important, it's very wise to deeply discuss this decision with business. Is it a good decision to build a custom feature for that guy? And then how do we maintain that stuff? Is it worth it? Do they pay enough? Or is it a feature maybe that could other people use it as well, right? So it's a technical problem, but also might be a symptom of a deeper business problem.
Good answer. I saw maybe there was one more question over here somewhere.
Let's do a last one. From Leon from Crypto Community. It's the third question from Crypto Community today.
So I wanted to ask about your code review practices, because you were talking about those small feature branches. And the first question is, do you do the pre-commit code review or the post-commit code review called audit? So can the code go into master and then be deployed without the review? And then if you do this pre-commit code review, like how do you deal with context switches? Because if the feature is developed in an hour, then someone expects it to be reviewed in an hour. And that's like a lot of context switches.
It's an excellent question. Maybe someone in my team can reply.
Ship code.
Okay, Piotr wants to reply. Give him a mic.
So when it comes to context switches and code review, we try to have people who are actually working on the code before do the code review, and because the branches are very short-lived, we try to first finish our own work. So because the work takes not a lot of time, we finish our own work, we submit our branch, and then we are off to review the other branches. So in this way, we are not distracted for the present work, and then we can also focus on reviewing other people's code.
Also, a masterful answer. That was even clear for me, and I don't get anything. The thing that shocked me the most was talking about branches that can last for only about an hour. Is it really? I mean, things are changing that rapidly and constantly. Really, a branch that lasts for an hour? Oh my God!
True story.
You guys are amazing. Once more, let's please thank our speaker because it's a fantastic presentation.